start the 4-1. And so chapter 4 is actually the last chapter we do for the college algebra part of the class. So we'll be finishing chapter 4 up next week. And then we start getting into the trig. And I'm going to kind of see where we get this week and determine when that second exam is going to be. It's going to be before spring break. It's looking like it'll be the week before spring break, which is the way it's almost like students who have 5 classes. That's usually the way their next test is. It's just kind of the way things work out. So that's where it looks right now. Whether I do it the Monday or Wednesday before spring break, I'll have to kind of look at that then. Okay, so to begin with, what we're going to do is a composition of functions. And a composition of functions is really saying this. You have some function, like in this case, this is x squared. And you're plugging in maybe a number into that. Okay, this is just a diagram I found on the internet that shows what a composition of functions is. So if you did 3 to the second, you would get 9. So that output of that first function is 9. So what you do is you input that into another function. Okay, so that's a second function. So then you would just do 9 plus 1, so you would get 10. So what you're really essentially doing is you're beginning with a function, evaluating it, and then you're plugging it into another function. So when you see the open circle, it almost looks like it says fog, that says f composed with g. That's a composition of functions. We sometimes call this a composite function. Okay, what you want to learn is how these two, the notation is the same. So if I say f composed of g of x, that really just means f of g of x. The g of x is the inside function, and then the f of x is the outside function like that. So really what we do is we get a new function out of 2 functions. Okay? And I'm going to talk about what the domain of this is as we go, so that'll make a little bit better sense to you. So I'm not going to really talk about that statement right now. So let's go down to this table. The first way I like to show students how to do a composition is just by doing a table. So I'm going to do a couple of these and then let you do a couple of these yourself. So what you're doing on this is you're doing f composed of g of 1. To me, this is what you should write on your paper immediately, is just write f bracket g of 1 bracket. You can use parentheses instead of the bracket too. So that chart that I gave you is going to tell you what g of 1 is. So all you got to do to find g of 1 is this. You locate 1, which is there, and g of 1 is 0. Okay, so the first row is what the function f is. The second row is what g is. So that means that g of 1 becomes 0, so now you're going to do f of 0. Okay? Tell me what f of 0 is by looking at my chart. Let me see if you know what I'm talking about. 5, good. Okay, there's 0, but f is the second row, so it's 5. So the answer to that problem is 5. Okay, you have to do that in that order. You have to do g of 1. G of 1 is 0, and then you got to do f of 0 like that. Does that make sense? What I did? Okay, there's an order to it. You got to do the g, then the f. Okay, the next one will be the same way. So you want to write this as f bracket g of 2. Okay, like that. All right, and I'll just kind of highlight what we're doing. So we're doing g of 2. What's g of 2? Negative 3. Good. Okay, so you can read from the chart. So this would now be f of negative 3. Okay, so what's f of negative 3? 11. Okay, so that's your answer to your problem. Okay, so that's how you're getting that information from a chart. Does everybody understand that okay, what I did? Okay, go ahead and try the 2 at the bottom there and see what you get. Just look at the chart that I gave you and see if you can figure out what those are going to be. This is a good way to start learning about function composition. Is basically how to do this with a chart. The next 3, I want you to do the next 3. And you can do like G of G. Just think through that G composed of G and that F composed of F. I mean, you can compose with one function. Nothing wrong with that. Okay, we got anything on the first one? 0? Is that what we're getting? 0? Okay, I haven't done them yet. I'm just setting them up. Okay, so you do f of 2. F of 2 is 1. So you'd be doing g of 1. G of 1 would be 0. Okay, so that's how that would go. You go in that order like that. Okay, how about the next one? 1. Okay, you get 1 on this. Okay, so this one would go like this. When you do g of 1, okay, there's 1. Okay, there's that. G of 1 is equal to 0. So you'd have g of 0, and then g of 0 is 1. Okay, just looking at the second row only, so that takes you back to 1. Okay, how about the next one? 7. 7, that's what I think I got, was 7. Okay, so if you do this one, it would go like this. So f of 3 is negative 1. So you'd end up just having f of negative 1. We'll go to negative 1. The second row on that gives 7. All right, so that's the answer on that. You should have got 0, 1, and then 7. All right, does everybody understand how that goes? How you read the chart? Okay, that's just one way to introduce the idea of a composition of functions. You're starting with the function on the right, evaluating it, and then evaluating that in the first function, like that, okay? All right, now what we'll do next here is we're going to take specific functions, and then we're going to find the composition. And these are, if you know how the order to do this in, they're easy to do. The first way to write f composed of g of 4 is just to write this as f bracket g of 4. Start the problem the same way you did the last problems. And then what I would do at the side of my paper is I would just do g of 4. Okay, well, you just need to plug in the 4 into the function called g. So that would be 1 minus 3 times 4 to the second, like that. So that would be 1 minus 3 times 16. So that would be 1 minus 48. So that's negative 47. You can just kind of do that piece right there on scratch paper. And then going back to the problem, you would have f of negative 47. Okay, we may have to use a calculator on this next one because we're probably going to get a real big number. So what do you do with the negative 47? You plug it into the other function, right? Okay, so you're going to end up doing 2 times negative 47 to the second. I'm going to do that on the calculator. I don't have a clue what that is. And you'll get some pretty big numbers on these sometimes. So I just do 2 times negative 47 squared. You'll get a positive number on this. So I am getting 4,418 would be the answer to that composition then. Okay, that's the idea, all right? Okay, so you got to do that in the right order. Okay, the next one, I would start off, I'd always kind of write this step out like this, write that as G bracket f of 4. Okay, we're kind of just doing this backwards of the problem we just did. So if we're going to do f of 4, then what you need to do is just plug in the 4 into the function called f. So you need to do that first. I'm going to do that the side of my paper. I just have f of 4 is going to be equal to 2 times 4 squared. So that's 2 times 16. So that's 32. Okay, so that's going to give me g of 32. And then what do I do with the 32? I plug it into G. So that goes in like that. So you would just work out 1 minus 3 times 32 to the second, and you can just do that on the calculator. We'll just do that in one step. So I've got 1 minus 3 times 32 to the second. That should give me a negative number. So that is negative 3071 would be what the value of that composition is. Okay, it's like that then. Okay, so that's how you do a function composition if you're given two functions. The functions tell you the arithmetic for the rule that you're going to do when you do the function. Okay, we're going right to left, okay, when you do that. Okay, all right, let me scroll this up just a little bit at the top. Go to the next page and do the next two, if you would, and see if you can do those okay. Use your calculator if you need to. These aren't too hard. This got arithmetic that you can do in your head. Okay, we got anything on the first one? 1. Yeah, 1. Okay, good. Okay, good. So you're doing f of negative 1. F of negative 1, again, you just plug in there. So that would be absolute value of negative 3. So that's equal to 3. Okay, so that's what you get is f of 3 now. Then you're going to plug back into f. Okay, so that's going to be absolute value of 3 minus 2. So that's equal to absolute value of 1, so that's 1. Okay, that's how you do it. As long as you do your arithmetic in the right order, you're okay. How about the second one? It's undefined, exactly. Because if you do g of negative 2, if you plug in the negative 2 into g, you end up getting 3 over 0. That's undefined, so there's nothing else to do in the problem. Okay, sometimes a function composition will be undefined, so you want to look for that from time to time. Okay, everybody solid on what we're doing there? Okay, just make sure you kind of work right to left, do the right function, get the result, plug it in the left. Got to do this in the right order. All right, so the next thing we're going to look at is given two functions and actually finding the composition. So if I have a x there, I'm not given a specific number, so you are formulating a function out of these two functions, okay? So what we want to do with this, and we're going to do the composition both ways, and sometimes what will happen is sometimes you'll get the same answer when you do the composition both ways, sometimes you won't. If you get the same answer, okay, then there's something kind of special about that. All right, so to begin with, on this first one, let's do f composed of g of x. So I would just write on my paper, like I've been telling you to do, just write that as f bracket g of x. Now what you're going to do is you're going to plug one function into the other one. So the way I always kind of tell students to do this is write down the first function. The first function's 1 over x plus 3. So I would write down 1 over blank plus 3. Like that. And what you're going to do is you're going to take that second function and you're going to plug it into x like that. So all you're doing is just plugging g, the whole entire g, into x. So what's going to go here is negative 2 over x like that. That is the function composition. Write the first function down, plug the second one in. Now what we have to do is we have to do some algebra on this to get this simplified then. Okay? So we're going to do some simplification. You're going to get into some complex fractions and stuff like that in this section. Okay? Complex fractions sometimes students have some background issues with. The way I look at this is I want the x to go away. So all I really got to do to make that x go away is multiply the bottom by x. Everything in the bottom by x, but then I have no choice but to multiply everything in the top by x, because I'm really multiplying by 1 over 1, so I'm not changing anything. Okay, so what you would have is you would have this. Numerator 1 times x is x. Denominator, see, I'm doing a distributive property. And you can do this in your head, but I have negative 2 over x times x. Then I have plus 3x. Well, notice that that cancels out. The x's cancel out. So you would end up with x over negative 2 plus 3x. And you could write that as 3x minus 2. It doesn't matter what order you put that in. Okay, so you're going to deal with complex fractions from time to time when you do that. Anytime you get a complex fraction, try to figure out how to get rid of all the denominators. Multiply top and bottom by whatever it takes to do that. Okay, does that make sense, what I did? Okay. All right, let's do this backwards. Now, when we do this backwards, what we're doing is g composed of f of x. Okay, so again, I'm going to write this as g of f of x. You can use parentheses instead of brackets. That doesn't really make any difference. Okay, so what you do is you write down g first. You always write down the first function. So the first function is g, so that's negative 2 over something. Okay, so what you do is you're doing this backwards now. So the f of x is equal to 1 over x plus 3. So that's what's going to plug in right there, is that x plus 3. Okay, so if I plug that in, I just have 1 over x plus 3. So I'm just doing it totally in reverse, and then you need to simplify this. So there's a couple of ways you can simplify this. That division bar is or that fraction bar is a division symbol. So you could think of this as negative 2 divided by 1 over x plus 3, right? Okay, how do you divide by 1 over x plus 3? You do the reciprocal. When you divide fractions, you multiply by the reciprocal, so that would be negative 2 times x plus 3 over 1. Then you just distribute that out, and if you distribute that out, you would get negative 2x, and then minus 6. So that's the function composition. So notice that when we did this one way and then the opposite way, we got a different function. There are times when you get the same function, but most of the time you don't. Most of the time it works one way but doesn't work the other way. Okay, it gives you something different. Okay, any questions about that? You understand the plugging in part, that's the key thing, and then just whatever algebra exists in the problem. So I'll let you do one of these. Let's just do both the one on the bottom both ways. So you want to do the f composed of g of x. You want to do it that way first. And then you want to do it backwards, g composed of f of x like that. Okay, I think you'll probably get a different answer on these things too. So remember, you write the first function down and plug the second function into the first function. So you'll get something different on these two functions. Okay, we got anything on the first one? X plus 2. Anybody get X plus 2? Okay, all right, okay. That's what I'm getting. I'm just kind of doing that in my head. So, yeah, what we'll do is we write down the first function. The first function is x squared plus 4. So you just write it as something squared plus 4. And the other function just plugs into it. Okay, so you do this. So the setup of this would be to do it like that. Okay, what happens to the radical when you square it? Comes off. Okay, so that's going to give you x minus 2 plus 4. So that's going to give x plus 2. Okay, so that's what that function composition is if you did that correctly. Okay, how about the next one? What we get? Square root of something, I guess. What did you get? Okay, I got square root of x squared and then plus 2. Is that right? Okay, that's what I was trying to do that in my head. Okay, so what you do on this is you write down g. So you do this backwards. Okay, g of x is the square root of something minus 2. Okay, so what plugs in there is the other function, the x squared plus 4. Okay, so that goes in like that, and then that's what you simplify. So you write down the g and then plug the f in. So what you'd end up having here, it looks like it's just x squared plus 2, and you can't go any further than that. Okay, you can't break that up and do anything with the radical. You're done with the problem at that stage. Okay? Does everybody understand what I'm doing okay? Okay, I want to make sure that you know how to do function compositions back and forth. Composition of functions is a big deal in calculus when you learn how to do derivatives and something called the chain rule. So you'll be dealing with the idea of a composition of functions in calculus here and there. Okay? All right. On the next page, what we're going to focus on, the rest of the focus of this section, mostly is on domain and range of compositions of functions. And I usually show a little bit different way than the textbook does, that I think is a little bit simpler. But the key thing is, if you're doing a composition, you always have to start with finding the domain of the function on the right. So in this case, you would do the domain of g of x and make sure you follow that first. Then you got to consider this. Now, I don't usually show it this way. The textbook says set up the function on the right to anything you exclude from the function on the right. This is supposed to be left right there. You need to scratch that out. I'm not going to teach it this way, though. I usually just tell students to find the composition of g of x, do the composition, and then find the domain of whatever your result is. Okay? So on this one, what we have is we have two functions. So I have, this is f of x, and that's g of x. So what we're going to do is we're going to do the domain of f composed of g of x. So the first thing you do is you just look at g of x and you figure out what its domain is. Do you know what the domain of 2x plus 3 is?
Everything.
It's everything, right? Okay, it's a line, right? X can be anything. There's no number that you can't double, right? So everything works there, so we'll just say all real numbers there, and that's good enough, okay? So we have all real there, okay? Now what we're going to do is we're going to go ahead and just find the composition f composed of g of x, okay? So that means f of g of x. So we're going to go ahead and just work it out. Now you don't necessarily have to multiply it out and simplify it. Once you get the composition, you want to see if you understand what the domain would be. Okay, so what you do is you write down f of x and kind of build a framework. F of x is something squared plus 3 times something minus 1. Okay, what goes in the parentheses? The other function, right? Okay, so what goes here is what g of x is. Okay, so what goes there is you would have 2x plus 3 plus 2x plus 3 like that. Okay, now if you can tell me what the domain is, you don't even have to finish it up. Is there anything that x couldn't be in this composition? No. Okay, you can double any number. You can double any number. And you could go through and do that. Now, I'm going to go ahead and multiply it out, but you don't have to. So if you square this, remember the shortcut I showed you, square the first term, that's 4x squared. Square the last term, that's 9. Multiply together to get 6x, and then double that, to get 12x. Okay, that's the shortcut we've talked about. Now you can write it out twice on scratch paper and FOIL it too, but that's what you would get. Then we do a distributive property here to get 6x plus 9. Then I just bring down the minus 1 like that. So if you put together your like terms, you would have 4x squared plus 18x. And then 9 plus 9 is 18 minus 1 is 17. Okay, what kind of function is 4x squared plus 18x plus 17? That's quadratic. And a quadratic function, what's the domain always? It's a parabola. All real numbers, right. Okay, you can square any number and you can multiply any number by 18. So the answer is just all real numbers. Okay, so you could just say all real numbers. If you did that in interval notation, you can just say that. If it's all real numbers, you can just state it's all real numbers, and that's fine. Or interval notation like that. Okay, so that's how that one goes. That's a pretty simple one to do, is g of x was all real numbers, and then when we did the composition, we had all real numbers also. Okay, so that's why I'm going to show you how to do most of these, is find the last function, and then do the composition and figure it out from there. Okay? All right, so if we look at the next one, we're going to start by looking at the domain of g of x. Okay, hopefully you can do that in your head. So is there anything that x could not be on g of x? 1. Can't be 1, right? You have a 0 denominator. So let's just write this in set builder notation. Let's say the domain of g of x is the set of x such that x is not equal to 1. So when you write the domain of the composition, that will be a part of it. X can't be 1 when you do the composition. That's important. So don't overlook that. Now what we're going to do is go ahead and do the composition. So we're going to do f composed of g of x. Okay, so this is just f of g of x, and then do your function composition. So what we're going to do when we do this composition is write down the f. F is 1 over x plus 2. So I'm going to write 1 over parenthesis plus 2. It's 1 over something plus 2. What goes into the parenthesis on this problem? The other function, right? Okay, so you plug one function into the other one. So what goes in here is the 4 over x minus 1. Okay, now this is a complex fraction. Okay, what you need to do on this, and sometimes students have a really bad background for this, I need to make the x minus 1 go away. So how do I do that? Multiply by x minus 1, top and bottom. If I want that to go away, everything in the bottom and the top has to be multiplied by x minus 1. So what I'm going to do on this is we're going to show that we're multiplying the top by x minus 1 and the entire bottom by x minus 1. Okay, with a little practice, you can learn how to do this in your head. I'm going to just kind of write down what the steps are. So the numerator is just 1 times x minus 1 is x minus 1. The denominator, you're doing a distributive property. So the first thing you'll have is 4 over x minus 1 times x minus 1, which is going to, of course, wipe that out. Okay, then you multiply it by this, so that's going to be plus 2 times x minus 1 like that. Okay, and you can do that in your head if you want to. So when I simplify this, I'll have x minus 1 over 4 plus 2x minus 2. Okay, so that means that what we get for our function composition is we get x minus 1 over 2x plus 2. Okay, so we got that. Now we're ready to do the domain. Okay, so that's the function composition that we have. Now what you're going to do on this, to find the domain of this composition, what do you got to do? You figure out what makes the denominator 0, right? So you would have to do 2x plus 2 equals 0. And you'd have to solve that equation. Okay, so that would just be x equals negative 1. Okay, so what this would mean is really it would mean that x is not equal to negative 1. So there's two things we got. We determined that x can't be 1 for g of x. Then we did that. So you have to throw both of those things out in your function composition. So the answer to the problem would be set of x such that x is not equal to 1 and x is not equal to negative 1. Or you could say x is not equal to plus or minus 1. The thing that students are kind of bad about doing on this is forgetting all about g of x. So if you have to throw something out of g of x, it has to be in your answer, okay? Because you have to have, you got to, in order to do a function composition, g of x has to be defined. If it isn't, you can't do anything, okay? That's the idea. Okay, is there any question about that? Yeah.
Why don't you find the domain of f of x as well?
It turns out that it really doesn't matter, because if you're doing a function, what matters is you got to make sure that's defined so that you can plug it into f. So you remember this problem you did a little bit earlier? Let me just kind of go to this problem. Remember the one you did where it was undefined a little bit earlier in class? I don't remember which one it was. This one? Okay. So the idea is if that's undefined, then you can't even get f. But if it's defined, it should work in the composition. Okay, it should always work in that composition. So you don't have to really worry about f, because you're worried about what is defined on G in order to plug it in. And then that composition, you might have something else that you can take out of that. Okay, so it turns out it doesn't really matter. And let me show you something on this problem. Is, for instance, if you took, f of x is undefined at -2, but what would happen is if you plug -2 into g, you would have 4 over -2 minus 1, so that would be really -4/3, and if you plug that in, you're going to get an answer. So it doesn't really matter.
Well, what if g of x equals -2? Like whatever number you end up having that plugs into g of x equals -2, and then you go to plug it into f, and it's like.
Well, it won't matter because of the composition. So if once you got the composition, see, the composition didn't have the -2 in the denominator. Okay, f of x has -2. You can't be -2. But if you look at the composition, it's okay for x to be -2. So that's why you got to look at g of x and then focus on the composition. Does that make sense? Kind of? Okay, g of x is real important. And then just look at the composition. Okay. Okay, so let's see. I'm going to let you try to do this and see what you know here. So you want to figure out what you think the domain of g of x is. That's a square root. We learned how to do that. And then you want to just do the function composition, see if you can put this together then. So step one is just figure out the domain of g of x. You guys remember how to do that if it's got a radical, square root? What kind of number has to be under a square root? Or 0. It's okay to do the square root of 0, right? Okay, so remember what you do. Just a little review here is that's how you do that. If you solve that, then you got the domain of that. So go ahead and do that. Then do your function composition and see if you can put it all together. So what's the domain of g of x? X greater than or equal to 1, right? So what you've got to remember is you have a square root. What's under the square root has to be greater than or equal to 0. It has to be. So if you solve that, you would have x greater than or equal to 1. So that will be a part of our answer. That has to be in our answer, okay? We're never going to get an answer to g of x unless it's 1 or bigger, okay? When you do the function composition, you're just going to write down f of x, which is 2x plus 3, then you're just going to plug in. So that would be this. And you don't have to do anything with that. That's your function composition. How are you going to find the domain on that? You're going to do the same thing, right? Okay. So when you do that, you're just going to say x minus 1 greater than or equal to 0. So it has the same domain. And you never know until you plug that in. So the answer to the problem is going to be x is greater than or equal to 1. Okay. Or if you wanted to write that in interval notation, it would be 1 to infinity. Okay. So the idea is, as long as x is 1 or bigger, g of x will give an answer. And then that'll guarantee that the domain had this, the composition had the same domain. So that's the idea. Sometimes this is one of the harder parts of this section. These examples I did are typical way you do it. Okay, do g of x, then the composition, and try to put them together. Okay, so that would be the solution on that. And by the way, there's a way to tell you're right. You could actually graph. If you graphed 2 times square root of x minus 1 plus 3, it'll tell you whether your domain's right or not, okay? So the thing on this is, if you put this in, you're going to have a square root function, which we've certainly learned how to do. That would look like this, okay? It's got, it's right 1, it's plus up 3, and it's got a vertical stretch to it. So if you do that, notice that the graph only exists from 1 and beyond. So it starts at 1, and that's it. Even if you go to your table of values, check this out. See how you have a bunch of errors when you're below 1. So you can verify that this is okay on your calculator if you look at it. Okay, just don't forget to put in the g of x domain also. Okay, so the last thing we'll do on this is just look at a graph and do this. This is kind of like what we did at the very beginning when we had a table. It's exactly the same idea. So with this one, what we're going to do is start by writing this as g of f of 1, like that. And first of all, just look at your graph and figure out what f of 1 is. Okay, well, the function f of x is the v-shaped one, the one that looks like an absolute value. So what is f of 1 just by looking at your graph? It's -1, right? Okay, it's that thing right there. Okay, so that means your second step is you would have g of -1. It's the same thing we did on the chart a minute ago. Okay, now look at g. G is the second function. So what is g of -1 on the graph? That's the one that kind of has the loops on it. What is that? There it is right there. Okay. X is -1, g of -1 is 3. So that's just looking at your graph then. F of 1 is -1, so that's f of 1, and then g of -1 is equal to 3, okay, like that. So that's how that one would go, okay? Okay, same thing here. You would do f bracket g of 0, like that. Okay, what's g of 0 look like? What? When x is 0, what's the value of g? That's the looped function. That looks like a 5 to me, right? Okay, right there is g of 0. G of 0 is equal to 5. So you'd have f of 5. Okay? What's f of 5? That's the V-shaped graph. So what's that? 1. There's your answer right there. Okay, that right there is g of 5, or no, f of 5, sorry. So f of 5 is just equal to 1. You're doing the same thing you did on that chart in the first page of your notes. That's the idea, okay? So you can get function values out of graphs as well. Go ahead and try the next two, and then we'll just stop here since we only got a few minutes left. And just see if you can run through the thought process. What do you got on the first one? You got that yet? 4. Okay, that's 4. Okay. All right. And let's see, the next one, let's see, g of 2 would be this. So g of 2 is 2. So you're really doing f of 2. And then f of 2, what's that? There you go. Okay, just a matter of evaluating that and looking at that the correct way. Okay. All right, any question about that? Okay. All right, so that'll wrap us up for today. I'll go ahead and let you go. Next time you have a written assignment 3, that's on Canvas. So if you haven't printed that out, be sure to print that out. And then we'll be turning that in. I'll give you back your written assignment 2 on Wednesday. I'll grade those probably tomorrow afternoon. And kind of update your grades to a point where I just kind of update every week from here on out.